So this is a continuation of the last part. Actually, thanks to Richard Paul. So he's the one that who draw this thing. But actually, this graph has a lot of credit. Okay, so this one, it helped me. Actually, this graph, it helped me a lot to understand how the control system are and this kind of thing. So I want to just discuss about this one. So in a previous lecture, definitely I screwed up. So I was supposed to explain what is a stable system, unstable system, this kind of things first. But I discussed about the critically damped. Okay, so all the things that I discussed in the previous lecture, all of them, they were a stable system. Okay, what is a stable system? A stable system is that something that doesn't blow up. Okay, so all the natural system is mean that something that humans they don't manipulate. They are by default, they are stable. But to make you understand what is the stable system, let's discuss what is the unstable system. Okay, unstable system is this kind of thing. Okay, so unstable systems, they are very easy to detect. Okay, so if something is unstable, okay, you will definitely know. Okay, because why? If something is unstable, either somebody die, either somebody lose an eye or lose a hand, okay, or something burn or something explode, or at the minimum, okay, a fuse gone, or at least your servo drive will be tripped and he will give you an error. Okay, the best case scenario is that, for example, you have a servo driver or something like that, he give you an error that, okay, something is not right. Okay, but when unstable happen, it means that things goes wrong. Okay, so in worst case scenario, somebody an injury can happen. So in my company, I used to have a chart where I captured one unstable system that it happened to me. It happens. Okay, so if especially in your tuning, so this is the reason unstable system is very important. Okay, if you do a mistake and unstable system happen, okay, something goes wrong. Okay, so and tuning, you have to understand tuning. Okay, you cannot to just tune anything just without knowing what's going on. Okay, if you do go tuning, just play. Okay, you can, how to say that, you can, bad things can happen. Okay, so you have to at least understand what's going on. Okay, so this is the reason that you have to understand the importance of being stable and unstable, those kind of things. Okay, so normally how the unstable things happen is something like this. When we do the control system, we have some sort of oscilloscope or some sort of things like that. So all the things that we draw here or this kind of thing, you see it in something called motion oscilloscope or something like that. So you have some sort of thing to measure all these things that we discuss about. Okay, but what will happen is that the unstable system, they normally start something like this, and after that they blow up. It means that there would be some sort of oscillation. After that, this oscillation grow until something burn or something it broke or something like that. Okay, but it doesn't stop. That's the issue with the unstable system. It means that, for example, it grow until something. So this still, this thing has applications of bomb or something. You want to create a bomb. So this is the application, but for example, something like industrial situation, industrial automation. Okay, so this is the thing that unstable system is a thing that it is a big no. Okay, you don't want to be falling in the unstable. So the second, what is the second category? The second category is on the border. It means that they are not neither stable, they are neither unstable. So how these things look like is exactly look like this. Okay, so for example, sine wave. Okay, so sine wave alone. Okay, so it is neither stable or not unstable. Okay, but it doesn't die. If okay, so all the stable system, they die. Okay, it means that they eventually they will come to a constant value or something like that, or even they oscillate. Okay, but their oscillation get smaller or smaller, this kind of thing. Okay, maybe this oscillation take forever, but they have a converging point. It converge or something. Okay, but for example, something like, for example, oscillators. Okay, oscillators, they are not converging to anything. Okay, they are oscillating forever. Okay, they never reach to something or something like that. Okay, so you may think that this one does not have any application, but in reality, in control, for example, in the automation, for example, you see lesser application of this one. Still in automation we have application, but this thing definitely have an application. Okay, the biggest application of this one is oscillators itself. For example, clock. Okay, clock is the best oscillator. Okay, so for example, I don't know, you see the clocks that, for example, they have a pendulum, right? So they are oscillating between 2 points without stopping, right? So this is exactly the things that you want for this kind of things. Okay, so clock is the best example. Beside the clock, another example of these things, for example, is, for example, digital clocks, for example, PLLs, those kind of things. All these things, they are oscillators. So okay, this one has an application, and the last one is the one that I discussed in the previous one. Okay, so in the previous one, as I discussed, also the all overdamp, underdamp, all the stable systems, or for example, the stable system, it means they have a converging point. Okay, all, for example, this top one, okay, you see there is an oscillation, right? But the oscillation, maybe it takes forever to this thing to die, okay, but still he is converging toward a point. Okay, it's trying to reach to a some sort of steady state or something like that. Okay, it will reach to a constant value. So this one regarding this, so I think I did a good explanation so far. Definitely see this video from Richard Paul. Okay, he explained this thing, he explained the way that he visualized this thing. I love it. Okay, so he is very good to, it is very good to understand this thing. Okay, so in the next video, I still want to talk a little bit before we move into the PID tuning, this kind of thing. I want to talk a little bit more about this picture. Actually, this picture say 1,000 words. Okay, this is such a valuable asset you have, you understanding you have in your toolset. So thank you for watching, and see you in the next video.